Okay, grade 12 mathematics, November 2015, paper 2, memo. That's what we're going through. We're going through the mathematics paper 2 examination from November 2015. This is the memo. So anyways, we don't like to waste time here. So hey, yo, it's upside down. Why are you upside down, boss? Why are you upside down? Let's just get this going. And yeah, again, gonna blaze through this one for sure. But anyways, question 1 says the table below shows the total fat. Ooh, the total fat in grams rounded off to the nearest whole number. Okay. And energy in kilojoules rounded off to the nearest 100. Triggered. Is this physics or chemistry or what? But anyways, let's move on. Yeah, rounded off to the nearest 100 of 10 items that are sold at a fast food restaurant. So in a fast food restaurant, these are 10 items. They're giving us the calorie count. Not the calorie count per se, but the nutrition and whatnot. That stuff at the back of the package. I don't know, whatever you call it. So this item has 9 grams of fat and this amount of energy going on and on and on. So here they say it represents information above in a scatter plot. Ooh, on the grid provided in the answer book. We got no answer book, whatnot stuff here, so we're going to need to draw one on our own. So I'm going to scatter plot. I mean, the first thing, just an axis, a y and the x axis, and then yeah, we have to look at our data nicely. We have to gauge it. So clearly, this is like going in. These are big numbers, you see. So I would have even gone in 500s, but yeah, that's gonna be a bit of a yeah. So this one is going to be a bit funny. Yeah, very, because I mean, look, our data here goes up to like like something around 30, and then here this goes up to around 2600. So let me just do the one on the x-axis first, you see, because this, it's easy to put this one on the x-axis, this one to put on the y-axis. So for 3 marks, you don't want to overthink anything. So let's just label it first, you see. Let's put here fat, and then this is in grams, you see. That's a mark already. Here, let's label it, what you gonna label it? So energy, it is in kilojoules, so let's put here in joules. Okay. Hey, I wish I had written it a bit further back, because now I've messed up my spacing. But anyways, here, if it's going to end up at 230, let's try 5s. 5s seem like a good pick, but is it really ending up at around 30? Yeah, it looks like it, yeah, it looks like it. So let's look. Is it ending up? Yeah, it's around 30. Why am I even confused here? I must just chill and just do the things, because yeah, that's what we're seeing here. It's ending up roughly around 30, somewhere there. So let's count in 30s here. 5, 10, 15, 20, 25, 30. Yeah, 5, 10, 15, 20, 25, 30. I mean, look, there is no 30 here, right? Nope. So it's fine if you have 30 as the highest. So let's see here. You see 9 is roughly close to 10. So you see what you can do is 10 should be roughly around 1,000, you see. So yeah, you see, just above 1,000. So here what you can do is for your scale, 1,000 would be like, let's make it somewhere there, maybe. Let's make 1,000 here. So let's put 1,000 there. Because what we're trying to use is, it is close to 1,000, this is close to 10. So 10 and 1,000 should be, so let's make this one 500. Let's count in 500s here. 500, 500, another one, going on and on and on and on and on. Let's say here 1,500, 2,000, 2,500, and then this is 3,000. Some people may be angry at me here, but hey, me, I'm just plotting the data according to the what, because that's what we're given here. So let's see here. 9 is around 1,100. So let's say 9 is like somewhere there. Woo. And then let's see here. 14 is like 1,300. So 14 is like somewhere there. So 1,300 is just before 1,500. So let's plot it over there. Let me pause this for a bit. Yeah, let's just carry on plotting. let's see here, 25, 2,100. 25, 2,100 would be like somewhere over there. Then let's see here, 2, 8 and 300. Oh, okay, that's fine. 8 and 300, that's like somewhere over there. And then you have 12 and 1,200. 12 would be like somewhere there. 1,200 would be like somewhere there. Ooh, this is hard. 31. Haibo, how did I miss this 30? I feel so blind. Like, that's just crazy. 31 would be like somewhere there. And then we have 2,400. So 2,400 would be like somewhere just before the 2,500, somewhere there. And then you got 28 and 2,200. 28 is like, somewhere there. 2,200 would be like somewhere over there. This data is funny. 14 and 1,400. So it's 14 and 1,400 again. Well, you see, these two look exactly very alike. So you see, 14 and 1,400. You see, these are going to be very close to each other. So let me just put a dot over there. And then you got 29 and 2,600. 29 is like somewhere there. 2,600 is like, somewhere up there. Because it's going to be above the 2,500. Let's put it somewhere there. Yeah, let's put a dot there. And then, 20. Finally, the last one. 20 is 1,600. So it's like somewhere there. It's a crazy looking scatter plot. But anyways, I think we have done our best. So you draw the points, you put everything, and then that's it. They'll give you how many marks. You see, it's just 3 marks. So make sure to label them. You see, label, put your scale, put your points. Yeah, missed 1.1. That was quite an annoying question. Quite boring. But anyways, let's move on. The equation of the least squares regression line is this. Okay, an item at the restaurant contains 18 grams of fat. Calculate the number of kilojoules of energy that this item will provide. Give your answer rounded off to the nearest 100 kilojoules. Okay, so our least squares regression line equation here, this is technically giving us something that we can use to estimate energy if we have the fat, and to estimate the fat if you have the energy. So we said fat is clearly, we can consider that x, this we can consider that y. So where x is, we can put 18 and then find our value for energy here. So in our equation, y is equal to 154.60, oopsie, plus 77.13, x is 18. So let's put this all in the calculator and find out what we get. This is what? 1.2.1. Yeah, so let's just see what this is going to give us. 154.60 plus 77.13 and then 18 and then boom. Okay, well, this is your answer before you round it off to the nearest 100. So this to the nearest 100, what you look at is technically this 4 when you compare it. This 4 is smaller than 5, so this is not going to change. Then it's just 1,500 kilojoules. That's it. So this one we can move on to, this is 1.2.1. So 1.2.2, what does it say here? Draw the least squares regression line in the scatter plot. Well, your least squares regression line, you see here, I need a ruler again, and I don't have a ruler, and y'all are gonna really eat my head off if I don't use a ruler. So let me go get a ruler. Got me the ruler. So let's draw our least squares regression line. So this least squares regression line, we need to make sure that it at least goes in between our points, you see, like something like that. So this will be perfect. You don't have to make it oh, this is actually perfect. This ruler can stand on its own. Not, it cannot. Let me just make sure I press it down there, and then where's the pen? Just throw this. Come on, man, come on, we're doing just fine. Okay, be steady, please. Finally, your least squares regression line. You're fine. You see. So remember, your grid paper will have nicer measurements and all that. So yeah, you'll be fine. So you can just draw your line like this. That will be good enough for 1.2.2. So you see, you get your 2 marks there. I could even label it 1.2.2 there. Anyways, identify an outlier in the data. I mean, this one question. I mean, look at this one. This one is like proper outlier because it's so far from everyone else. So this one is going to be our outlier. So here, the fat is 8, the energy is 300. So here, I mean, this is our outlier. You see, yeah, there's nothing much to it here. You see, this is our fat. You don't have to write this, but you know, fat, energy. See, that does not look like it correlates. But anyways, moving on. This is 1.3, man. Come on, bro. 1.3 because we just did 1.2.2. Don't mind my handwriting. Sorry for the neatness. Not very neat. But I think I'm neat in some way. Like, you know. But hey, let me just carry on. Calculate the value of the correlation coefficient. The correlation coefficient is our value for R. So to get your value for R, you unfortunately have to put all this data in your calculator. You see, you have to put it all in your calculator. So you have to press mode and then stat and then 2 again. And then you have to put all this data. Starting with X, meaning all the values at the top. So let's do here 9, 14. Hey, 14. You must be careful here because if you put in the wrong numbers, it's over. You know, it's chai. It's over. I'm not even kidding. So anyways, let's just do this. So while I'm doing this, might as well, you know, plug me. I was getting carried away here. Then I noticed I did not put the 10th number, which is 20. Whew, that was going to be scary. But anyways, so yeah. On Teachable, well, if you check in the description, well, by now it should be there. You will find there's a link to like the courses that I make, like full math courses. When I say math courses, I mean, for example, the main one is like functions and graphs, like a full course on functions and graphs, where basically I go through like everything you need to know about functions and graphs. I mean, I know with my main channel I have tutorials on functions and graphs, but then the course is basically like if you don't know anything and you want to start from scratch and you want to learn everything and understand it 100%, then that course is definitely gonna do the things, because yeah, it's in depth. You can find the link in the description for the courses and stuff. Anyways, now we've put in all your data. You press on, and then for you to access your correlation coefficient, you press shift and then 1, and then you go to reg, which is 5, and then you press 3, which is R, for your least squares regression line. So R here is equal to 0.95. That's to 2 decimal places. You see, that's it. So moving on, 1.5 here says comment on the strength of the relationship between the fat content and the energy in kilojoules, or the kilojoules of energy. So we need to show the relationship between these data. So clearly our value for R is quite high and it's very close to 1. So here you have to say very strong, and then you have to say what number this is. This is a positive number. Very strong positive correlation. You see, very strong positive correlation. This is going to give you your, how many marks is this? 1. You see, it's just 1 mark, so not a big deal. Even if you don't spell correlation correctly, you'll get all your marks. So for question 1, hey, quite a boring question, I won't lie. But anyways, let's move on to the next one. Okay, so for this question, I'm going to show you something very interesting with the calculator. I think it might save you some time. You will just need to look carefully. So anyways, with this question, it says a group of 30 learners. Okay, 30 learners. So all these should add up to 30. A group of 30 learners randomly rolled 2 dice once, and the sum of the values of the uppermost faces of the dice is recorded. The data is shown in the frequency table below. So what they mean is people had 2 dice, so meaning they had 1 dice, you see, Ian, and then had another dice, and then they put these dice in their hands, and then they threw these dice at the same time, and then when they land, whatever the numbers are at the top, they added them up and then they recorded them, you see. Okay, so here they said, you see here saying sum of the values on the uppermost faces. So when you add it up, when they got 2, 0 times. When you add them up, they got 3 times. They got 4 twice, going on and on. They got 12 once. So here they said calculate the mean of the data. So let me show you how you do this. You want to put this data in your calculator first. This is how you do it. So you want to look very carefully here. So you have to press shift and then mode, you see. And then you see these options, you have to go down. And then you see here there's stat. So you're going to press 3. And then it's telling you frequency on. So you want to turn the frequency on, so you press 1, you see, to turn on the frequency, because you have a frequency table here. It goes back here. Then you press mode. Now you can press stat for 2. And then you want to choose 1 for var 1. And there you go. You see, you have got this data and the frequency. So now you can put this data first. You see, 2 equal, and then 3, and then 4, 5, 6, 7, 8, 9, and then 10, 11, and then 12. You see. So let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you see you have 11 pieces of data. Then you go back up, go all the way up, and then we want to put in the frequency. So the frequency here, you see it's going to default it to 1, so you can just change it. It's 0 here, and then you have 3. You have to be careful here, you see. Then you have 2, and then you have 4, then you have 4 again, then you have 8, then you have 3, then you have 2, yep, and then you have 2 again, then you have 1, and then you have 1. So you may be thinking to yourself, is this fine? I mean, look, it's an 8 mark, it's a 2 mark question. So you put all your data in the calculator, right? Why is this 1? Oh, it is 1. The last ones were 1s. I thought they were stuck 1s. But yeah, these last 2 are 1s. So you've put all your data in your calculator, and then you can just press on now. See, now you want to use it to get the mean. So to get your mean, you can say shift and then stat. Then you can go to var, which is 4, and then this is your mean. So you press 2 there, and then equal to, you get 6.73. So 2.1, you can put there, your mean is equal to 6.73. So you can put your calculator. You see, calculator gives you that. That's for 2 marks. So yeah, that's just that. Because all you're doing is you're saying 2 0 times, and then 3 you have it 3 times, 4 you have it twice, going on, you're adding, and then you're dividing everything by 30. You see, yeah, that's what you're doing. You're literally saying 2, I have 0 of them, you see, plus 3, I have 3 of them, plus 4, you have 2 of them, plus 5, you have 4 of them. You see, going on and on, and then you're going to divide this whole thing here by 30, which will give you 6.73. But you see, your calculator does that for you. The median of the data, there are 30 learners, you see. So the median, you have to find where learner number 15 is. You see, where learner number 15 and where learner number 16 is. Because that's where the middle is going to be, you see, between these 2 learners. Because you see, 30 is an even number. So the middle is going to be between learner number 15 and learner number 16. So what you do is you have to add up your learners. So you have 0 learners here, and then plus 3, plus 2, you have 5. Plus 4, you have 9. Plus 4, you have 13. Plus 8, you will have, let's see, 13 plus 8, that's going to give you like 21. You see, so it means that your median is in this group here. You see, because you are adding learners, right? You have 3 learners, and then you have 5, and then you added 4, you have 9 now. Added 4, you have like 13 now. So when you add technically 2 more, you know, you end up between learner number 15 and learner number 16. So the median is in this group, the group of people that had the sum of the values on the outermost faces is the guys that had 7. So if you think of it, well, here technically learner number 15 and learner number 16 is going to both have 7, you see. So you could put here for yourself, what is this question? It is 2.2. So for 2.2, learner 15 is 7, and then learner 16 also have 7. So the middle of 15 and 16 is your median, right? So 7 plus 7 over 2, that's just going to give you 7. If you did not do these calculations and you just wrote 7, you should still get your marks, because I mean 15 and 16, they are both 7s, so that's fine. That's how you get your median. That's 2.2. Now we're going to 2.3. So for 2.3, it says here determine the standard deviation of the data. You see, that's where your calculator comes in now, because you see your calculator has that stuff. Shift, stat, and then you want to say var. This is your standard deviation. So you press 3, and then it is giving you 2.26. You see, 2.26. And you see here, this is just 2 marks, because that's just calculator work either way. For 2.4 says determine the number of times that the sum of the recorded values, I have to do it again, determine the number of times that the sum of the recorded values of the dice is within 1 standard deviation from the mean. Show your calculations for 3 marks. So with these kinds of questions, determine the number of times that the sum of the recorded values is within 1 standard deviation from the mean. So questions like these, they may throw you off, but this is all you need to do. You have to take your mean, you minus standard deviation once. And then you take your mean, you add standard deviation once. Let's do that first before we carry on. So the mean is this number. So let's take our mean. It's 9.76, right? Yeah, 9.73, man. Come on, Brody. Come on. Yar. Ish. Yeah. No, 6.73, you minus your standard deviation once. And then you take 6.73 again. You add your standard deviation once. So you're going to get 2 numbers here. Let's get those 2 numbers. 6.73 minus 2.26. Let's see what this number is. It's 4.47. Okay. And then you do it again. You see, 6.76 plus your standard deviation, you get 8.99. 8.99. Okay, so you see they said within 1 standard deviation. So you add your standard deviation once, you remove your standard deviation once. If they said 2 standard deviations, you take your mean, you minus your standard deviation twice. And then you take your mean, you add your standard deviation twice. So what you have gotten here is a range to work with. Now, any values, you see here they said determine the number of times that the sum of the recorded values is within 1 standard deviation of the mean. So technically, we have to work with whole numbers here. So here, you could think to yourself, well, what? Yeah, let's just see this again. Determine the number of times that the sum of the recorded values is within 1 standard deviation of the mean. Within. So when they say within 1 standard deviation of the mean, then you see here we have to take the whole number here, meaning we have to always round it down, unfortunately. So you have to round. Technically here we cannot have 4.47, as an answer. So you have to round this down to 4, and then this one you have to round this down to 8. So we have to pick all numbers that are within this range. All numbers that are within this range, we have to pick them. You see. So numbers between 4 and 8, where 4, well, technically here, you may be thinking to yourself, but wait, hold on. 4.4. This one, let me just, this one technically has to be 8, because you see, you have to round it down here. This one though, if you're thinking of 4.47, then technically you have to start from ones that have 5. You see, let me just say that again. You see, because you're thinking, you want to work with face. You want to work with the sum of the values on the outermost faces. You remember this is the lowest one you can consider, but you see this is not a whole number. So the lowest whole number you can consider is going to be 5. You see, because 4 is below this number, so you cannot consider 4. So you have to consider ones that are starting from 5 until ones that are ending at 8. You see, because for 8.19, the nearest whole number you can consider is 8. So we have to pick all the values. We have to count how many values are between 5 and 8. So funny enough, you see, it's going to be these ones here. You see, it's going to be 4 people plus 4 people plus 8 people plus 3 people. So let's see here. 4 plus 4 plus 8 plus 3. That's going to give you 19 learners. Or 19 times where that happened. No, not 19 learners. Well, yeah, technically 19 learners. Yeah, it happened 19 times for 19 learners, you see. Because they said, yeah, determine the number of times. So you can say 19 times, actually. If you said learners, same thing, really. Determine the number of times that the sum of the recorded values of the dice is within 1 standard deviation of the mean. So you take your mean, you remove 1 standard deviation. You take your mean, you add 1 standard deviation. And then because we're working with what the sum was, technically the closest one here has to be a 5, because you cannot consider 4, because 4 is below this number. Then the closest one here is going to be 8, because you cannot consider 9, because 9 is above that number. So anything between these two values is just 5 and 8. Anyone that was getting 5, 6, 7, or 8, you pick those numbers. It's giving us 19. So that's that for question 2. So let's just move on to question number 3. Okay, as always, we are definitely not wasting any time because nobody got time for that. But anyways, moving on. Question 3 says, in the diagram below, the line joining the line joining P and Q. In the diagram, the line joining P and Q. Haibo, what's wrong with these descriptions? Come on, man. Fine, the line joining Q and P. Here it says, in the diagram below, the line joining P and Q, A and B, where A is bigger than 0 and B is bigger than 0, makes an angle of 45 degrees. Okay, fine. You could have just said that better, actually. Yeah, it makes an angle of 45 degrees with the positive axis. And then it says PQ is 7, let's just label that, 7 square root of 2 units. N is that coordinate, is the midpoint of PR. And then it says M is a midpoint of QR. Okay. So we got the midpoint theorem going on here. And remember, the midpoint theorem basically states that if this line here cuts QR in half and it cuts PR in half, then automatically, if this is 7 square root of 2, this one is going to be half 7 square root of 2. That's your midpoint theorem. And automatically this has to be parallel to that. You see, you need to know your laws. Just before we have just before we dig into this question, that we already know. You see, PQ, whatever PQ is, it is double whatever MN is, because of your midpoint theorem. Your midpoint theorem says that if you have a line that goes from one midpoint of a line to another midpoint, and that's like in a triangle, then this one has to be half whatever this one. And then this has to be parallel to that. But anyways, let's get into our question. Get the gradient of PQ. Well, you can get that using your tan formula. You see, tan 45 should give you the gradient of PQ. So let's just do that. Tan 45 is equal to M, the gradient of PQ. Let's see what tan 45 here is. Tan 45, that's going to be a 1, kablamo. It's just like gradient is 1. Very nice. Very simple, easy. You get your marks, you run. No time to waste. Anyways, the next question now says, for how many marks? How many marks you offer? 4. Oh, thank you. Thank you very much. Says, get the equation of Mn. Where is M? Mn in the form y is equal to mx plus c. Wow, these guys are so nice. Such nice people. Because, Mn, we have to show that it is parallel to PQ. Let's say that first. Mn is parallel to PQ. Reason is midpoint theorem. I mean, like, would you look at that? You can actually say the midpoint theorem as a reason, because I mean, they told us this is the midpoint, this is the midpoint, so we have the midpoint theorem. So these are parallel by default. I mean, isn't that fantastic? Therefore, the gradient of mn is going to be equal to 1. So we have the gradient, you see. Y is equal to 1x plus c. So to get the y-intercept, technically we need a coordinate that the graph passes through, and we have it. The y value is a 1, the x value is a 7, and then here you just have 1 minus 7, c is equal to minus 6, and that's it. Therefore, y is equal to x minus 6. Easy peasy. You see, it's a 4-mark question. It did not take you 4 minutes, so you still are banking time here with these easy ones. Calculate the length of mn. You see, they're only making it a 2-mark question because we know that mn is half whatever pq is. The reason is the midpoint theorem. You see, if you need to know more about the midpoint theorem, that's on the main channel. I think even the playlist of like tutorials on Bright Young Brains, the main channel, they're probably here as well. But then yeah, if you go on the Bright Young Brains channel, that's where I post like mini tutorials and stuff. The midpoint theorem is definitely there in like the Euclidean geometry playlist. Okay, mn, we said it is half pq. So here, therefore, mn is going to be a half whatever 7 square root of 2 is, which is just 7 over 2 square root of 2. Yeah, there's really not much to do here. If you want to put it in the calculator, you can say a half times 7 square root of 2 if you want, if you are one of those people. Yeah, this is going to give you 4.95 units, because you see we should round off to 2 decimal places. Here you see the stat stuff is still there, so you can just shift clear them and then all, press 3 there, and then yes, and then you can press just clear it, so it's gone now. Yep, we're not wasting any time with these easy ones. Length of RS. Where is RS? RS, Haibo. Why does this look like a parallelogram? We don't know, so we cannot assume. But it's a 1-mark question though, so it's quite tempting, you know. But as tempting as it may be, before we can say what we're going to say, we have to give a proper reason for it. Because if you don't give a reason, you're not going to get your marks. And you can't blame them for not giving you marks for stuff that you don't have a reason for. Hey, let's just see what they said about S. Did they say anything about S in our description? Nope. Haibo. This question now. I feel like this question does not have enough information. Like legit, I'm gonna skip this like a hot potato if these people don't give us more information. Because look, they told us this is 45, fine, this is 45, fine, this is midpoint stuff going on. But then here they did not say anything about S. So let's see what the next question says. The coordinates of S, calculate the coordinates of S such that this is a parallelogram. Ha! But then we need the length of RS. Well, funny enough, I'm not joking, but this question does not have enough information for us to get S. Firstly, before this question, they did not say anything about this being a parallelogram. And yeah, this is a mark that everyone was probably given in this exam, because there's absolutely nothing here to get S. If they told us it's a parallelogram, then we could do something, but they didn't. The next question wants us to prove, the next question wants us to get S if it's a parallelogram, but then this one, you see, I mean, you cannot get RS if you have not gotten enough information. Like the description says nothing about S, so we cannot make any assumptions about S. So, oopsie, this is error. This is error. Should I say error or what? Well, whatever it is, let's say missing information. Missing info. So yeah, in whatever past paper you're going through, if this is what RS is, you'll see RS is missing. As in, there's nothing to do to get RS. So this one is out. 3.4. Yeah, so everyone that wrote this 2015 paper got this free mark. The coordinate of S such that, we should get the coordinate of S such that PQRS is a parallelogram. So this one is quite easy, because if this is a parallelogram, then technically our midpoint theorem has to hold. You see, if this is X, X, and this is Y, this has to be the midpoint. So you can just use our midpoint theorem, you see, because n is the midpoint of SQ. So in our midpoint formula, we're going to say the midpoint of SQ. So the midpoint, let me actually write it out. Midpoint of SQ is equal to x1 plus x2 over 2, y1 plus y2 over 2. But we have the midpoint of SQ. It's n, you see. We have it. It's 7 coordinate 1. And then here it's just x1 plus x2. And then y1 plus y2 over 2. So here technically the 7 is equal to the x part. And then the 1 is equal to the y part. You see, because this is the x value of the midpoint, so it goes with this. Y value of the midpoint, so it goes with this. Y1 plus y2 over 2. So the good news is, I mean, with our midpoint, we have x1 and y1. It's just -2 and -3. So let us make use of those. Ah, man, I cannot flip over my paper. I was about to. Yeah, I cannot. So let's say here. So 7 is equal to, the x value here is -2. So here you can have -2 plus x2 over 2. So you see the x2 is going to be this value here. And the y2 is going to be this value there, because the midpoint is there, you see. So here, times by 2 on both sides, you have 14 is equal to -2 plus x there. And then here you have 16 technically, you see, because the 2 goes over. So this is, you have that. And then here you're going to have 1 is equal to the y value. We chose -3 there, so -3 plus y2 over 2 times by 2 on both sides. I am blazing. We're moving, people. We're moving. Not wasting any time, because why? Then there you go. So here, therefore, S is going to be, this is a 5, by the way. 5 coordinate 16. You write that down. Don't mess it up now. The X value is 16. How? This thing. There we go. 16 coordinate 5. You write that down and you move on. You run. Okay? Don't waste any time. Oh, my paper fell. Where'd you go? Come back. We need you later, but we can keep you there for now. Where we get to now? Coordinates of P. For 6 marks. Where's P now? Okay. Oh, yeah, we're gonna finesse this question. Watch us finesse this question now. Anyways, so what we're going to do is, you see, wait a minute, this is going to be actually tricky. Oh, this is funny, because if we had R, getting P would be easy, but it don't look like it's going to be that easy. It looks like this question is actually going to be quite long. Let's think. 6 marks. Okay, finally a thinking question. What would I do here? Well, technically we already have the distance here, so we can use the distance formula and have an equation that has A and B in it. That's the first thing we can do. Secondly, what else? Wait, oh snap, RS. Oh yeah, well, you see, the reason why I said there was missing information here is because they did not tell us that this is a parallelogram. But if they did, I mean, here you could have just thrown in 7 square root of 2 as a guess if you wanted, yeah, let's might as well throw that in there, even though the information is not enough. I mean, if you had to pull your weight and guess it, then by all means, guys, by all means, 7 square root of 2, throw it in there. It's a 1 mark question anyways. So moving on. I can't believe I just went back there. Coordinates of P. Yeah, let's firstly, because if you're going to get A and B, right, you're going to need to work those out simultaneously. So if you're going to work those out simultaneously, it means you need 2 equations and stuff like that. So let's get the distance equation here with PQ. So PQ is going to be equal to the square root. You can have your x1 minus x2 squared plus y1 minus y2 squared. You may write your distance formula differently with stuff swapped around, mixed around, whatever. It doesn't matter. Your choice. So I've already labeled these x1 and y1. So let me just keep it like that. Let me label this x2, y2. So this is like 7 square root of 2. And then what's the x1 now? X1, it was -2. So it's like -2. minus a squared plus negative 3 minus b. Negative 3 minus b squared. Okay, so we have one equation that is a and b. So let's try and see if we can get another one. Well, I could try and finesse this question and do funny things, but why? There's really no need, you know. So let's just chill a bit and think nicely. What did we... So when you get to a point like this, try to ask yourself, what did our... You want to ask, what did our equation... What other questions did we have to get here? We had to get the gradient of this, and then we had to get the equation of mn. Well, funny thing is, I mean, if we had the equation of mn, fine, we can... I mean, P is a point on this line here. So we could also just get the equation of this line. Because if you get the equation of this line, P is a coordinate that that line passes through. So we can just label this equation 1. The next equation, let's get the equation of PQ. So here, mx plus c. Well, technically the gradient is a 1. We already have that. So the y value here, I mean the y-intercept, we can just throw in a coordinate that the graph passes through. So negative 2 and negative 3. So here x, negative 3, no, y is negative 3, x is what you call negative 2. So here you're going to have negative 3 plus 2. Your c value is a negative 1. Therefore, the equation here is y is equal to x minus 1. So you see, here you can throw in a value for y, which is b. And then you can throw in a value for x, which is y. So you see you have a value for b here. So you can throw this into that. Yeah, let's say here 2 into equation 1. Let's see here, 7 square root of 2. Let me actually simplify this first as best as we can before we... but it doesn't matter really. Let's just throw it in there. Like, why wait? Why wait, Joe? Like, just shoot your shot. Just go. So here, minus 3 minus the b, which is a minus 1 squared, and then this is like 7 square root of 2. This is like let's FOIL this. Minus 2 times minus 2 is going to be a 4. Minus 2 times negative a is going to be a positive 2a. So you're going to have 2 of those, and the negative a times negative a is a squared. Yeah, all we did here, I always get so guilty for not doing it openly. So you see, negative 2 times negative 2 is 4. Negative 2 times that is a positive 2a. Negative that times that is another positive 2a. This times this is a squared. Then here you have 4 plus 4a plus a squared. Whew, okay, I feel better now. And then here minus 3, let's multiply inside. That's going to be negative a, and then positive 1. This thing is all squared. Here, 7 square root of 2, you have this whole thing here. You see, it's easier to throw it. Oh, I already throw it in, so I'm just getting a here now. This square root symbol, we'll deal with it later. Let's just see here. This is just 4 plus 4a plus a squared. Here, technically, it's going to be negative 3 plus 1. That's like negative 2. Would you look at that? This is exactly that. So we can just also simplify accordingly. So this is like 4 plus 4a plus a squared. You see, this is just a coincidence, by the way, so don't get it mixed up. This is just a coincidence. So here we have 4 plus 4a plus a squared, and then there. So we squared this bracket, and then this is 7 square root of 2. If we square both sides, let's see here, squared, this is like just use the calculator, boss. 7 square root of 2, the whole thing squared, is 98. Okay, very nice. 98. This will come to that, and then you have, you see, these two. Look carefully here. This plus itself means you have 2 of them. 2, 4a plus 4a plus a squared. You see, you're plussing 2 things that are exactly the same. So here, if you multiply inside, it's like 8 plus 8a plus 2a squared. It is 98. And then let's take everything to one side. Squared plus 8a plus 8, and then minus 98. So this is 0. And then this is technically, I mean, this is going to give you 90. Wait, don't be judgerach. Yeah, that's going to give you a 90. So, what the hell am I doing? I feel like I've made a mistake again, but let's just check nicely. I hate making mistakes. Mistakes are so annoying. You know, it's like, yep, yeah, wait, no. Huh. Now, let me just carry on. We'll just see at the end if we get answers that make sense. Anyways, here, A is going to be equal to minus B plus minus B squared minus 4AC over 2A. In the calculator, please save us. Save us, calculator, save us. Plus this thing here, let's see, this is going to be, what you got, 8 squared minus 4, 2, and then that's like negative 90, and that's like 2 times 2, 5. Okay, that looks normal. So A is a 5. We will take that as believable information. And then here B, we know B is technically going to be A minus 1, so B is equal to 5 minus 1, so B is a 4. So therefore P, the X value is 5, the Y value is 4. So yes, perfecto, we are happy, Okay, let me chill. Not start acting like a madman. But anyways, this is all we had to do for this question. Let's move on to question number 4. And we're blazing. We're doing well on time. Let's move. So, anyways, here we go. We got another question here. It's question number 4. In the diagram below, see, not wasting time. In the diagram below, we've got Q, and it says it is the center of the circle center of the circle that intersects the y-axis at P. Okay, so Q is the center of the circle that intersects the y-axis at P. M and M is, no, it intersects the y-axis at P and M. And then it says here, the tangent APB at P intersects the x-axis at B, okay, and makes an angle of alpha with the positive axis. R is a point on the circle, and PRS is equal to theta. Okay, that sounds okay. All nice and dandy. Let's just move on. Be quick about it because, yeah. Determine the equation of the circle in the form this. Easy peasy lemon squeezy peoples. Right? Anyways, we have our radius. We can get it by this line. Our center, we have it. So these are easy 3 marks because you see A and B, this represents the opposite of the center. This represents the opposite of the center. So if this is 5, this is negative 5. This is 2, this is negative 2. So here, X, you see here we said you have to put a negative 5. So let's put negative 5 there. And then here you have to put a negative 2. So let's put here y minus 2 equal to r squared. So let's just get r. Remember, r is the radius. So we know that r is equal to the square root of, we can just use the distance formula here. So this is like 0 minus 5. That's like 0 minus 5, the whole thing squared. And then you have here 6 minus 2. 6 minus 2 squared. And then let's put all this in there. We don't have to put the calculator. I mean, like, why? So much work. This is going to be 25. This is going to be 6 minus 2. That's 4 squared. That's 16. So you have square root of, I'm lazy to think all of a sudden. 41. Yeah, you know, strange answers. It's fine. 41. Square root of 41. That's our value for r, you see. So therefore, our equation is going to be x minus 5 squared plus y minus 2 squared is equal to square root of 41. I like to do it like this, but you can do it as whatever you want. If you want to just cancel these, you can. If you want to leave it like this, you can. It's really not a big deal. So let's move on to the next one. Get the coordinates of S. How many marks you give? You see what I did there? Always check what your mark allocation is. I feel like a machine and a robot when I do these math questions, because I always react in a very specific way. I want to know what the mark allocation is so that you know how much you need to think. So the good news is, I mean, what else did they give us here? They gave us Q. We have the equation of the circle. So this, we already know what the point is here. The x value is a 0. The y value we don't know. You see, so we can get this point by throwing in 0 into our equation of our circle, we're going to get two solutions. One is here, the other one is down there. So let's just do that. So in our equation where x is a 0, let's find out 0 minus 5 squared. Where x is a 0, let's do here what our y values will be. Our first y value should be a 6. The other one is the one for s. So here you can just write it as 41 because this cancels that. And then here now this is like 25 plus here y times y is y squared. Y times negative 2, that's going to happen twice. So you're going to have negative 4y. And then negative 2 times negative 2, that's a positive 4. Yeah, I do feel like what I do there might irritate some people. Goodness. Oopsie. Yeah, I just cannot bear the thought. So y times y is y squared. This times that is negative 2y. This times that is negative 2y again. This times that is 4y. 4 on its own. Then y squared minus 4y plus 4. Boom. Okay, we're happy. Everybody's happy. Solving for y here, you can just use the quadratic equation if you want. But after you simplify, obviously. So what here? This plus 4, that's going to be 29. So let's do here plus 29 is equal to 41. Y squared minus 4y plus 29 minus 41 is equal to 0. I mean 20 what times what's going on here? This, if 29 minus 41, let's see what that is in the calculator. Calculator, please tell us. Negative 12. This minus 4y minus 12 is equal to 0. Yes, I'm going to use the quadratic equation because I use the quadratic equation for absolutely everything. I mean, what you gonna do, huh? Okay, let me stop it. Just stop. That's so useless. Anyways, if you factorize though, factors of 12, that would give you a 4. It's just technically going to be 6 and 2. So here you can say 6 and 2, so you technically need negative 6 plus 2, you see. So here you're going to have y is equal to 6 or y is equal to negative 2, because if you factorize this, you are going to have the y minus 6, y plus 2. You see, I can do both, but I like the quadratic equation better. If you put this in the calculator, you get 6 and negative 2. But then this one is for the p, you see, because there are 2 points where your graph is equal to 0, where your circle is equal to 0. So this one you can remove it. So therefore s has to be, the x value we know it's a 0, the y value is a negative 2, and you move on, you don't sympathize with easy questions, you move on. Okay, moving on to question number 4.3. Determine the equation of the tangent APB. How many marks? 4. Okay. So where you start is what? Wow, okay. Let me think. Oh, ISO. So you have the radius there. So you can use the gradient of the radius to find the gradient of APB, because you see they meet each other at an angle of 90 degrees. So it means their gradients should give you a negative 1 if you multiply them. So let's get the gradient of PQ actually. The gradient of PQ is, let's just, y value is right. So it's 6 minus 2, x value is next. It's 0 minus 5. That's like 4 over negative 5. So therefore, the gradient of APB, is going to be this number flipped over, so it's 5 over 4, and then you change the sign, so this is a positive value. But for those that did not like that, this is all that happened. You see, the gradient of PQ times the gradient of ABP should equal negative 1, you see. So if you put the gradient here, negative 4 over 5 times MBP, this is the gradient of ABP, by the way, divide by negative 4 over 5 on both sides, you're going to get negative 1 divided by that value. If you check in your calculator, negative 1 divided by that value, 4, 5 with the negative here, you see you're going to get a positive 5 over 4. But the easy way I like to do it is you can just flip over the fraction, change the sign. Whatever value it is, you can flip it over, change the sign. But if you like to do this, you do you. So we have the gradient of APB. So technically, if you have the gradient, you can always get the y-intercept by subbing in a coordinate that the graph passes through. But look, this is already a y-intercept. So you already know that c is equal to 6. So y is equal to 5 over 4x plus 6. You don't have to work it out. I mean, they low-key gave it to you there. So just throw it in and move on. And yeah, keep moving because ain't nobody got time to waste. So what's the next one? 4.5. Let's write it out. 4.5. Let's see how fast we can get this paper done. Like, I'm really, really keen on blazing through it. I'm not even planning on wasting any time because ain't nobody got time for that. Get this. You see, 4.4, guys. Come on. You see, we're lost. We're already getting carried away here. We just did 4.5, 4.3. So let's do 4.4. They want us to get the value for alpha. This is going to be easy because you have the gradient of this line already. What is that gradient again? 5 over 4. So here 10 alpha, you know, gradient is 5 over 4. So if you go shift 10, be careful what answer you get here. Let me show you something. Be careful what answer you get here. Don't take it at face value because you know trigonometry is always dumb. It always do funny things. But anyways, this one is fine. It's an acute angle. You're looking for an acute angle, so this is absolutely perfect. Nothing wrong with it. You can round it off to 2 decimal places there. If let's say you wanted a value here, then you would obviously just do exactly what we did, but then you would remove this value from 180. But anyways, no major issue here. 4.5, calculate the value for theta. How many marks? You see, that was a reflex action because I want to know. My hands are shaking because I'm literally moving. No, I think they're shaking because my hand is tired of holding this camera. Stay strong, hand. Stay strong, okay? Come on. What the hell? Motivating your own hand. Yeah, you got to, Baba. Well, the easy thing here is, you see, this is our 10-chord theorem. I just literally just saw this now. How amazing. You have the 10-chord theorem playing out here. See, so if this is theta because you see you have a circle here. Look. 10-chord theorem, ISO. You see, angle between the tangent and the chord is equal to the angle here, which is subtended by that chord. So let's just tell them we know that BPO, let's just write that out. BPO, we know that it is equal to theta, not Q, it's equal to theta. What's our reason? 10-chord theorem. 10-chord theorem. Yes, that's our reason. So after that, we can now focus more in this triangle here. You see, because this number is 51.34. We worked it out. So let's just actually draw that triangle to emphasize where we're going to get our marks. So this is P, this is B, this is O. This is a 90-degree angle by default because look, it's the x-axis and the y-axis. This is 51.34. I mean, this is given. I mean, look at this. This is so easy. Therefore, BPO is equal to 180 degrees minus 90 minus 51.34. This is going to give you, what's your reason here? Let me put an arrow. Interior angles of a triangle. Okay. Yeah, this is perfectly fine. Everything is working out so super. And it's only a 4-mark question. So it's like, not only, that's a lot of marks for just something so easy. This is to show you that, you see, maths does not care what you're doing. Whether it's analytical, wara, all your laws still apply. So you see, that's your value there. You get your answer. You move on. There's nothing much to it. Yeah, I feel like I dropped something. I hope it was not something important or something that I'll need later. But anyways, moving on, because this is 4.5. We have 4.6 next. Calculate the area of PQS. Let's see. Where's Q? QS. Well, this one is going to be easy again. Why? Euclidean stuff. Look here, because look, this is theta, right? We got it to be 38.66. This is also theta, so it's 38.66. Technically, this is double that because an angle at the center of a circle is double the angle at the circumference. Yeah, let's tell them that. So we have to tell them here 4.6. Let's tell what. So you may be asking, why are we doing this when they're asking for the area? Well, it looks as though we're going to see, this is our triangle, right? There's P here, there's Q here, there's S here. If we know this angle, good. We know these two, good. We can use the area rule to get the area of that triangle. So what we're doing is, let's firstly tell them that PQS is double R. PQS is 2 times whatever R is. The reason is angle at center of circle. Center of circle, you see. Therefore, PQS is double whatever this is, which we worked out to be theta. Theta is just 38.66. 38.66. And then, you see what we're doing here? You see, even though theta was here, we had to work it out using this thing here, because it doesn't matter where theta is. If you can use other portions of the sketch to work it out, do that, you know. It's all good. So here, 2 times that, that's 38.66. 38.66 divided times by 2, that's like 77.32. Okay, that's PQS. Fantastic. Let's just draw that image again on our answer sheet. I think that would help for the examiner. P hiso, and you got the S hiso, and this is red eye. So let's tell them that we know that also. You see, everything you know, tell them, Baba. Flood them with that information. PQ is equal to QS because they are red eye. Hello. And then we know that therefore PQ and QS is equal to the, remember the radius of the circle that we got. What was that radius again? It was square root of 41. Square root of 41. Yeah. Anyways, we have square root of 41 here. Square root of 41 there. So it looks like we're good to go in our area rule, because this value here, it is 77.32. So remember, your area rule says the area is going to be equal to half this side here, which is SQ, that side there, which is PQ, sine the angle, which is Q. Yeah, don't mind me. Let me actually write it nicer, guys. Area of what triangle? Area of triangle PQS. You see, it's going to be a half multiplied by SQ multiplied by PQ sine angle Q. Okay, let's throw in values. It's going to be a half square root of 41, square root of 41 sine 77.32. You can put that in brackets if you want. Let's put this in the calculator. Let's see here. A half square root of 41, square root of 41. Hey, what's this here? And then sine sine what? 77.32. 20. Yeah, you can just say that's 20. I mean, there's really no need. If you want to round it off, that's fine. Units squared. Round it off to what? To 2 decimal places. Yeah, you can. What's going on here? Yeah, that's what happens when you talk too much and you write too fast. 20 units squared. That's it. Let's move on. No time to waste. Remember, we are on a mission to we're moving, so let's not waste any single second. Question number 5. Here we go. Given that this is equal to k, very easy questions these. Determining the simplest form, the value of each of the following in terms of k. Well, I mean, you can understand. I mean, these have to be easy for me by now, because I've been doing so many of these. Like, if they were not easy, that would be a weird thing. Like, oh my goodness. So, hypothetically speaking, I mean, if anyone wants to get a distinction in maths, I mean, they could legit just go through all the papers on this channel one by one, and trust me, you're going to get that distinction if you put in the work. Obviously, but I'm sure you will. But anyways, they say here sine 23 is equal to square root of k, determining the simplest form the value of each of the following in terms of k without using a calculator. Okay, rule of thumb, put this over 1 first, draw a sketch, okay, and then 23 is the angle, so you're going to label this 23. This is opposite over hypotenuse, so opposite over hypotenuse. To get this value, you use your Pythagoras stuff. 1 squared is equal to square root of k squared plus x squared. Oops, this is x squared, by the way. And then now just solve for x. So here it's 1 minus, this cancels out, so it's 1 minus k because it goes over. Then you have x squared. Squared at both sides, you have x is equal to 1 minus k. So yeah, you can draw another one if you want. 1 minus k, the whole thing under square root. you have square root of k here, you have 1 there. Boom, 23. If you want to be funky, you can even get that other angle there. You see, because if this 23, this has to be 67 because you see interior angles of a triangle. Woo! And this is all in your answer sheet so that you can just blaze through the next few sets of questions, because these next few questions, as long as you have your sketch on your answer sheet, you can just run through them and get your free marks, like legit. So sine 203, so don't get carried away here or don't get blown away or whatever. Sine 203, well, it's a big number, so you want to write it in terms of 180 first. So let's do that first. 180, so what I'll do is, let's see here, 203 minus 180, that's like 23. So what we can do here is sine 180 plus 23. You see? And then sine 180 plus 23, this can be written as sine, let's see here our cast diagram, CAST, 180 plus, so you end up in this quadrant, sine is a negative. Okay, so negative sine 23 is what you should work out for this value, so that's going to be negative square root of k, because sine 23 is k. I mean, sine 23 is square root of k. So negative sine 23 is negative square root of k. 5.1.2. Cos 23. That's easy. You use your sketch, you see. Cos 23 means adjacent over hypotenuse. So cos 23, you have adjacent, which is this value here, over hypotenuse. Boom. That's it. Easy, right? And you may be thinking, am I going to get all my marks for just writing that? Yes, because you have got all your working out here. 5.1.3, 10 negative 23. So let's deal with this first. 10 negative 23 is the same as negative 10 23. Why? Because of the cast diagram. If you deal with the negative, you have to go clockwise first. So negative 23 gets you here. Negative 23 leaves you in this quadrant, and in that quadrant 10 is a negative. So yeah, because you're minusing, so you go clockwise. If you're adding, remember you always go anti-clockwise, but then if you're minusing, you start by going clockwise. So if you go negative 23, you end up here, 10 is a negative there. So negative 23 is just opposite over adjacent. You see, opposite over adjacent. So it's this value over this value. So that's going to be opposite over adjacent. Boom. Oops, sorry, didn't mean to scare anybody. That's quite dumb, weird. But anyways, you can just leave your answer like this. It's totally fine. Oh, there's a negative here, so let's put that there. And then, yeah, you can just leave it like this. It's not a big deal if you leave it like this. It's totally fine. Because these are both under square root symbols, you could put them both, let's say here, option 2. You could put them both under one big square root and have your k over 1 minus k with a negative. That's fine. If you leave it like this, it's also perfectly fine. I would have just left it like this because, I mean, you know, why not? Whew, I feel like I'm losing my breath just by running, like, your goodness. Anyways, let's just, yeah, go to this next question. So, yeah, let's just put in another plug here while I write this question. So, if you want to go through, like, math courses, you know, from start to finish to, like, relearn work and stuff like that, you can check that out. In the description there is a link to the courses that I make, and then yeah, you can definitely boost those math marks, you know, give them a bit of a, yeah, some energy, you know, buy them some energy drinks. Buy them a math course. But anyways, simplify the following expression to a single trigonometric function. We should simplify this to a single trigonometric function. And we're going to use things like double angles, compound angles, everything, reduction formulae. So let's start from the top here. The bottom, I mean, this one is blunt. This one looks exactly like looks like a compound angle question. I mean, it's so obvious. I mean, just look at it. I mean, you see it? Well, if you don't, let's just get you a formula sheet to help you. So if you look here, right? We're dealing with the bottom for now. We haven't started, but let's just deal with the bottom. You see the bottom, you have sine and cos, cos and sine. Look here, you see. You have sine and cos, cos and sine, you see. Where this is a plus here, that's a plus there. So you see, this thing here, you have it here. So you can simplify it into that. But let's just put this here for now, and then we will get back to it later. But the top, let's see. Firstly, cos with a negative angle. You see here, if you use your cast diagram again, if you go negative a value, you end up here. Cos is a positive there. So here you can just have 4 cos a positive value because it's a positive cos if you go negative a value. So you end up here and cos is a positive there. So you're safe. 90 plus. So you see 90 plus. You see you're dealing with a positive number, so you have to go anti-clockwise. So you go 90 and then plus. So you end up in this quadrant. But because you're dealing with 90, you have to change this to a sign. And then in this quadrant, right, cos is a negative. So you have to put a negative here. You see, we're changing because we're dealing with 90. We're choosing a negative because cos is a negative in this quadrant. You see, you choose according to where you're starting. The bottom, we said we have like compound angle stuff going on there, because look, we have like 30. Let me bring it close together so that it's easier. You see where this bracket is, you see we have alpha. Where beta is, we have x, and then where alpha is, we have, you see, again 30 minus x, and then this beta, we have x again. You see, so these are repeating. You see, that's how you know it's this compound angle stuff. So here, that can be bottled down to this, meaning you see where alpha is, you see it's this bracket here. So you can put here 30 minus x, and then you see where beta is, you have here, there. You see, that's just x and x there. So that's a plus, so you can just put a plus here and your value for x, you see. Whew, let's simplify. The top we can just simplify for now. It's going to be negative 4 cos x sine x if you want. I can already see the top looks like we're going to have some sine double angle stuff going on, but let's leave that for now. The bottom part, you have sine here, 30 minus x plus x. That's just going to be, let me write down the top like this. You'll see why just now. These are just being multiplied together, so you can swap them around if you want, and you'll see why I've swapped them around, so that we can do what we wanted to do next. So here, if you look at the top, this looks exactly like, it looks similar to this, you see, the double angle of sine, you see, but there's sine here and cos here, you see, sine here, let me bring it closer, man, come on, why you gotta be so far? You see, sine and cos, you have sine and cos. This is a 2, however, this is a 4. So what you can do is, you can take out a negative 2, and then you have 2 here, sine x, cos x, and then here you have sine 30. And then, yeah, this 30. Then this is technically your double angle, negative 2 sine 2x here, and then you have sine 30. I mean, they didn't say anything about not using a calculator, but either way, sine 30, you got a half there. So this is equal to negative 2 sine 2x divided by a half. So that would be negative 2 sine 2x. Let's put this over 1 and then divide it by a half. So that would be this value here over 1 times 2 over 1. This multiplied together would give you negative 4 sine 2x. Like that. So that's a single trigonometric function. You can just leave your answer like that. Negative 4 sine 2x. So that's all you had to do for this question. Let's move on to 5.3. Why is that baby crying? Ish. I don't know what that is. But anyways, let's move on to the next question. The next question wants us to get the general solution of this. So the one thing that stands out is it's a 6-mark question, and you see there's a double angle there. So because there's cos here somewhere, it may be wise for us to change this into this double angle of cos, into this identity of our double angle for cos. So here this is clearly going to give us a quadratic equation to work with. So thank you very much. I keep putting minus equal to where 3 is. Let's see here. Simplifying this, you have 2 cos squared x, and then let's say minus 7 cos x here, and then minus 1 minus 3, that's going to be negative 4 equal to 0. And then boom, here you can just use the quadratic equation because you have 2 here, something squared, minus 7, then something here, and then 4. See, quadratic equation stuff. So here cos x is equal to minus b plus minus b squared minus 4. A value is a 2, c value is a negative 4, and then your a value is just a 2 there. So here you have, let's use our calculator. Whew, minus b, hey, minus b, minus b is a negative value, so it's negative 7 plus b squared minus 4. A value is a 2, c value is a negative 4. Okay, that's comforting. 2 and then a. Yeah, so usually when your c value is a negative, that's always, you know, a good thing. So cos x is equal to 4. So this is technically not valid because a cos graph only goes between a negative 1 and a positive 1. You see, so this won't work. So the next one, let's see. Let's check this one out. That's like negative a half. Okay, that's reassuring because yes, our cos graph at least does go to negative a half, you know, at some points, at some time, you know, and you know, whatever. But anyways, so yeah, with here we have cos negative a half. So it just means what we need to do next here is we need to get our reference angle and then, you know, all that stuff. So yeah, let's just be careful here. So normally I always say, not normally, but I always say always get your reference angle by using the positive value here. So you're going to get your reference angle here is going to be cos, shift cos with a positive a half. Let's see what your reference angle is going to be. So your reference angle, shift cos with a positive a half. Let's see there, that's 60. 60 is the reference angle. And then now you need to ask yourself, in your cast diagram, where is cos a negative? It's a negative here and it's a negative here. So it's 180 minus. So let's do that quickly. So in the second quadrant, your x is going to be equal to 180 minus your reference angle plus k360. K is an element of integers. So here, let's see here. X is going to be 120 plus k360. K is an element of integers. In quadrant 3, technically that's going to be 180 plus. So you have x is equal to 180 plus your reference angle plus k360. K is an element of integers. You got 240 here. Yep. X plus k360. K is an element of integers. Easy peasy, lemon squeezy. You get 6 marks just for doing this. Like, imagine, like, oh my goodness, such a nice life thing. But anyways, this will be good enough. This here. You move on to question, what's the next one here? Question 5.4. Anyways, the next one seems like a super interesting question. Not too interesting, but it's okay. So here they say sine theta is equal to a third. Calculate the numerical value of sine 3 theta. So the funny thing with sine 3 theta is technically, I mean, this, you want to split it up into a compound angle stuff. Otherwise, yeah, it's not going to happen. So this is 2 theta plus theta. And then if you use your compound angle stuff, where did I put the formula sheet? But this one is fine. I already know it. It's just sine 2 theta cos theta, and then plus cos 2 theta, and then sine theta. Okay, so you may be thinking, why did I do this? Well, we've done this, and then now the only thing is, you see, there's so many signs everywhere. So it's best if we change this to a sine, and then this we can just leave it for now. You know, I don't think there's a need for us to change this for now, but let's just change it. Might as well, because if you leave it like this, it's not going to do us any good. So here, sine theta cos theta. So this is going to be sine theta cos theta, but then if you times it by cos there, it's going to be squared. Plus, let's change this to something that has a sine. Minus 2 sine squared theta, and then sine theta there. And then what I will do here is, let me actually change this to something that has a sine as well. So it's like 1 minus sine squared theta, plus this times this is going to give you sine theta. This times this is going to give you negative 2 sine cubed theta. This times that is going to give you 2 sine theta. This times that is going to give you negative 2 sine cubed theta. Yeah, I feel like something is going to be a mess here. I hope I did not make a dumb mistake, because I feel like I did, but anyways, I don't think I did. Then you have plus sine theta here minus 2 sine cube theta. These are like terms. These are like terms. Oh, look at that. This and this gives you 3 sine theta. This and this gives you negative 4 sine theta. And then now you're home free, because look, you have a value for sine theta, you see. It's just a third. So this is like a third. This is like 4, and then a third cubed. So this is like 3 times a third. That's like 1. And then this is like 4 outside. 3 cubed. That's like 1 over 27. A third cubed, 1 over 27. This is like 1 minus 4 over 27. Let's just check out what that is. Well, technically, this is like 27 over 27. So that's going to give you 23 over 27 in your calculator. Because you would have put there 27 over 27 minus 4 over 27. The top minus the top gives you that. The bottom stays the same. So, kablamo! We're not playing any games today. No games are being played here. We're moving. Funny thing is, a lot of these questions, some people have asked me them at some point in time. So it's almost like, wait, I've seen this question before. And then boom, 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 boom. That's why it's so fast. But anyways, let's move on now to question number 6. Anyways, there is definitely no time to waste, I guess. I feel like this is the theme of the day. No time to waste. No time to waste. In the diagram below, the graphs of f of x and g of x are drawn on the same set of axes from negative 240 to positive 240. So this is telling us that this one here is a vertical shift. This one here is a horizontal shift. You see? And then vertical means from top to bottom. Horizontal means from left to the right, vice versa, whatever you want to think of it. And then it says here the graphs intersect at this point and that point. Let's see here quickly. Okay, hello, meet over here, so, and they meet also over here. Okay, that's good to know. And then they said here, oh, another point. Where else? Where else? Tell us. Oh, here. Okay, thank you very much for giving us that piece of information. It's always nice when they're given a grid like this. But anyways, 6.1, they said determine P and Q. So they said P and Q are just shifts. So technically we see this is just a normal cos graph. Where's F? That's a normal cos graph. Now a normal cos graph normally goes between negative 1 and positive 1. So here it's going between a half and negative 1.5. So technically it was moved a half unit downwards, you see. So Q is technically negative a half, you see. That's just some theory that you need to know there. The graph was moved a half unit downwards. So the original one would go from here to there, but it's not going from here to there. So it was moved a half unit downwards. P, let's see here. The graph of sine, originally, what you want to remember is, you see the turning point here, look. Our original turning point should be at like 90, you see, because your sine graph does this. Oops, so this is here 90. You see, that's where your turning point would be. But your graph has a turning point at 60 now. So you see it has moved 30 to the left. So P has to be a positive 30 because it's moved to the left. Eesh, that's a very funny looking plus 30. But yeah, you know when you're running, you don't have time for neatness. It says here, determine the values of x in the interval negative 240 to positive 240 for which f of x is bigger than g of x. So the mean is, if you look at the graph of f of x, where does it have y values? You see, where does it have y values that are bigger than the y values of g? And that's only occurring in like one spot, and that's over here. You see, this is the only portion where your graph of f, what happened here? You see, that's the only portion where the graph of f has y values that are above the graph of g. You see, because here you see f of x is below, and then here f of x is below. So here this is the only portion where it's above g of x, you see. So for 2 marks, they just want you to give, it's an x value from negative 120 until 0, you see. Because there's not like an extra line here, you'll just have to say x needs to be bigger than negative 120, x needs to be smaller than 0, you see. Because that's not included because you see there's no extra line there. Option 2, you could have written it as x is an element of negative 120 until 0. like that, your choice. X is the element of. Hey, yeah, ne? No mess on this paper, no mess on this handwriting either. Anyways, it says here, determine, what must we determine here? So for 2 marks they said describe the transformation of graph of G. Determine the transformation that the graph of G has undergone to form the graph of h of x. So G, where is G? Hey, it's a coarse graph now. Oh, okay, that's kind of funny. Well, technically, if the graph of G, okay, always start with what you have. You see, the graph of G looks like this. It's sine x plus 30. So automatically, the one thing is, if it's going to change to a cos, then technically what has happened is that technically sine x plus 30, this can be written as cos 90 minus this here. Let me explain. So you know that cos 90 plus theta, no, cos 90 minus theta. Actually, let's just write it under cos 90, right, minus theta. This is the same as sine theta, you see. So where theta is, we have this whole thing here. You see where theta is, we have this whole thing here. So if you want to go from sine to a cos, this is technically what would have happened. So here we have here cos 90 minus x plus 30. This is like cos 120 minus x. So you see, this is just overcomplicated. This is just overly complicated, like too complicated. Let's make it a bit easier. So from a this is how many marks? 2. So we should not be overthinking. So from sine to get a cos, remember your graph has to be shifted at a minimum of 90 degrees. So when I say it has to be shifted a minimum of 90 degrees, well, let me just carry on from here, because why not? You know, why not? Let's see here. 120. What can we do there? Let me just pause a bit and think. So I think just using our sketch may be the easiest thing to do, because what we just want to think to ourselves is, what does negative cos x look like? Negative cos x looks like this. You see, where this is a negative 1, this is a positive 1. This is what, if you're looking at it from 0 to 360, this is what negative cos x would look like. So if you look at our graph of G, where is our graph of G? This is what our graph of G looks like. You see, so what we could do for ourselves is, we see, we technically want this thing happening. You see, this, and that. So for that to happen, if you think of it, we can focus on this point, and this point. You see, so for us to have this picture here occurring from 0 to 360, if you think of it, this has to be moved 1, 2, 3, 4. It technically has to be moved 120 degrees to the right. So that's the easiest way we can think about it. You see, so if you look at the sketch, this is the graph of negative cos x. For you to go from the graph of sine x plus 30 to this, your picture has to be moved 120 degrees to the right, because from 0 to 360 you would have this image here, and then obviously elsewhere you would have just another portion going on and on and on. So all this, I mean, that's all nice and dandy, you don't have to write it out, but then here you can just say g of x is shifted 120 degrees to the right. Kablamo. You'll get your 2 marks for that. It's theory, and you see, I try to overthink it, but as long as you don't overthink it, it's better, because if you overthink it, there's no point. It's just 2 marks anyways. Question number 7. I already made some notes, my bad. It says, in the corner of the rectangle, a corner of a rectangular block of wood is cut off and is shown in the diagram below. And then it says here the inclined plane is ACD, and then it says this is an isosceles triangle. So we were given this value. It is equal to this side as well, because it's an isosceles triangle. Then they say this is theta and this is theta, and then they said this angle here is half theta, and then they said AC, yeah, they gave us CD is 2x. Okay, good information. For 7.1, they said we should work out a value for CAD, C-A-D, in terms of theta. So let's see, C-A-D. So that one is going to be easy because interior angles of a triangle add up to 180. So CAD is just going to be equal to 180 degrees minus theta, which is like 180 degrees minus 2 theta. So that's going to be straightforward. So yes, we got CAD. Easy. The next one says prove that cos theta is this. Okay. Well, if you want to work with cos theta, you can use any of these angles. So let's work with this one here. What I mean is, if you look at that triangle, right, let's draw it out. If you want to use the cosine rule, which you definitely can, you can use this theta here. This side you have x plus 3, and then you can use this 2x. This side you have no. The cosine rule, yeah, you have this 2x and then you have x plus 3. So you see, you have an angle given here, and you have this here, and you have this here, and you have the opposite side. Well, you have so much information, you can use the cosine rule if you want. Because here, let's see, this is what? CDA, okay. And then we have, well, if you're going to work with this as your angle, this has to be opposite side. So AD squared has to be equal to this squared, which is AC squared, plus this squared, which is DC squared, minus 2AC times DC, and then you have cos ACD. Okay, let's put in the values. I mean, why not? This is just x plus 3 squared. AC is just, again, x plus 3 squared. DC is 2x squared. And then minus 2, this thing here, so it's x plus 3. And then DC is this thing here, it's 2x, and then cos theta. We want cos theta on its own, so let's just simplify first. So here I would not recommend you to square yet. Let's just leave it. Because look, this you can take it over, you see. It's going to be minus the same thing. Then this you can take it over, you see. It's going to be minus 4x squared. And then this you can just leave it minus, let's multiply this. Negative 2 times 2x, that's like negative 4x. And then negative 4x times x is going to be negative 4x squared. You see, this times this. Yeah, you see, I just multiplied these two together first. Negative 4x. And then negative 4x times x is negative 4x squared. And then, actually, let me actually not do things funny. Yeah, let me not be funny. Let's just make things easy. So here I can basically say this times this is negative 2x. This times this is negative 6. Let's keep those in brackets. Then you have 2x here, cos theta. Yeah, this cancels out. You have negative 2, you have negative 4x squared here. Now let's do this. Negative 2x times that is going to be negative 4x squared. Negative 6 times that is going to be negative 12x. And then cos theta here. Because we want cos theta on its own, this is going to be negative 4x squared. And then, yeah, we need to be careful here before we make a dumb mistake. Yeah, this goes over, so this is going to be a plus. Uh-oh. Snap, I feel like I made a mistake again. I hate making mistakes. Mistakes are so annoying. Like, have you ever, like, made mistakes? And then it's like, wait, what? How come, though? Oh, yeah, there's my mistake, you see. Because look, this we moved it over, fine. This we moved it over, fine. And then this here, you see, this times this is this thing here. This times that is this thing here. Remember, this is all pasted to the cos x. So this is one thing. I cannot do what I wanted to do just now. So, yeah. 4x squared is equal to negative 4x squared minus 12x cos theta. So here you have, you see, these two are being multiplied by cos theta. So I have to put this here and this there. Does that make any sense? It doesn't want to make sense. Like, make it make sense, please. Like, why does it look so complicated. Like, why? Anyways, let's divide both sides by this big bracket here. Negative 4 that minus 12x. This is in front of cos, so this goes away. And then you have negative 4x squared minus 12x. So let's take out common factors here. It looks as though we can take out a negative 4x squared out at the top. No. There's only one x at the bottom. This is the most annoying question. Why am I making so many dumb mistakes? So let's take out 4x squared as a common factor. Or rather, let's make it negative 4x squared. Yeah, negative 4x actually, only. So here we can have x left. And then at the bottom, if you take out a negative 4x here, you can have x left here. If you take out a negative 4x there, you can take out a negative, so this is going to be a plus. 12, so this has to be a 3. And then this goes away. Hey, this question was super annoying. If you're annoyed as well, I'm annoyed with you, okay? So don't be annoyed at me. I'm annoyed too, man. Goodness. Like, come on, let's just be annoyed together. But anyways, this is cos x is equal to this. If you wanted to use the sine rule, it would have worked out. This question was just so annoying. Let's just run away already. So this was 7.2. 7.3 says for 5 marks. 5 marks! It is given that x is equal to 2. Calculate AB, which is the height of the block. Okay, so what did we get here? We got a value for cos theta. Okay. That's nice. But is it really? This so... Hey, yeah, mathematics. Mathematics is boring sometimes. Where did that even come from? I don't know, man, but it's just annoying. Like, what is that? It's just so annoying. Oh, wait a minute. We got a value for x, so we have an expression for this. Yeah, let's start there, Before we start crying, let's just start there, Cos theta is x over x plus 3. So they told us x is a 2, so this we already know. Cos theta is 2 over 5. Okay, so they want us to get the height of AB. So getting AB, it looks as though we have many options here. But yeah, it doesn't look like it wants to be used as stuff. What am I saying? I don't know. I'm just literally just losing my mind here because I'm just like, what is going on? But let's just look at this question. Let me pause and think about it, Well, enough thinking. We can just get a value for theta first. I mean, like, what the hell? Cos 2 over 5. Let's just get a value for theta. It will definitely make our lives very easy. Because why not? Like, I feel so dumb. Like, right now I feel so dumb. Like, why is this so weird? Maybe it's because I'm just rushing and all that. And 66.42. So, 66.42. Okay, this is perfect. Because now we at least have a value for this whole angle here. And we have a value for this. So it looks like we can use some trigonometry here. Let's just do this sketch. There's A here, there's B here. That was such a blonde moment. This is x plus 3, you see, so that's a 5. So this is 5. And then this is half theta, So half theta, it is half of this. So let's divide this number by 2. It's 33.21. So this is 31.21, you see. So you can always draw this on your answer sheet so that they see where you're getting your answers from. Because you worked this out, they gave you this. You worked out theta, this is half theta, so you get this value. This is x plus 3, so it's 2 plus 3, which is 5. Now to get AB, you can just use trigonometry. This is opposite over hypotenuse, you see. So sine C is opposite over hypotenuse. So sine 31.21 is opposite over hypotenuse. And then you have 5 sine 31.21. This is AB. AB for 5 whole marks. This is actually a good 5 easy marks, like for real though, now that I think of it. Sine 31.21. Hey, what's going on here? Put in the blank brackets. How? Why you want to mess things up when I write at the end now? Let's see here. Let me just double check this answer. 5 sine 31. Why am I putting 31 over there? Come on, man. 66.42 divided by 2 is 33.21. My bad. I'm actually a bit annoyed at myself right now. Like proper. Because in an exam, imagine doing these dumb things. Hey. Yeah, no. 33.21. And I'm sure you were wondering, why is this dude putting the wrong values all the time? Like, dude, get next to yourself. Like, just get it right already. Like, what the hell, man? Stop doing the wrong things. Hey, moving on to question number 8, because this was just... Ugh. Woo! Question 8. Let's see if this will brighten up the mood, because hey, it's been annoying. It says, in the diagram below, a cyclic quadrilateral ABCD is drawn with center O. They said, complete the statement. The angle subtended by a chord at the center of a circle is double the angle subtended by the same chord at the circumference. You see, angle subtended by a chord at the center, so this angle here, right, is double an angle subtended by the same chord at the circumference. There, you see, so this one is double that one. Or 2 is double that one, so don't forget. Then it says here, yeah, no, we have to write it out. 8.1.1, double is the missing word. 8.1.2. It says, for 3 marks, use 8.1.1 to prove that A plus C is 180 degrees. Oh well. Well, I'm just going to use this sketch to prove that. So they want us to prove that this here plus this thing here add up to 180. So that's quite... what do you have to do again? Yo, this is funny. Oh, wait a minute. Yeah, let's just use this theorem, because it looks like we have, for this theorem, would have, if we did not have OB and OD, we would need to put them there, but they already gave us OB and OD, because those would be constructions if this theorem was just plain. Anyway, so the first thing you want to mention is that O is, you want to say O1 is 2A, you see, so let's do that first. O1 is equal to double whatever A is, because angle at center of circle. You see, O1 is double this. Now you need to say O2 is double C. You see, O2 is double whatever C is. Reason is, again, angle at center of circle. You see, because this is a reflex angle, so this angle is at the center, this one is the one being subtended by the same chord. So this is double that one. So luckily, all you did need to do, this is very easy, that's why it's a 3-mark question. O1 plus O2 is equal to 360. Reason is angles around a point. Remember, angles around a point add up to 360 degrees. So here you have O1, which is this expression, 2A, O2, which is this expression, 2C, and then obviously you can take out 2 as a common factor, and then voila, you have 360 here divided by 2 divided by 2. This goes away. A plus C is equal to 180. That's why they're only giving you 3 marks, because it's quite a simple theorem. I was about to leave it as 18, then most people would have been angry, like I would have been angry a bit too. So we need to go to 8.2 now, because this question was nice and simple, easy marks. Let's move on. 8.2 says, for 5 marks, in the diagram below, CD, where's CD? CD is a common tangent to the circles. No, common chord. Hey, that was very bad. It's a common chord, not a common tangent. And then it says here, line ADE, where is ADE? Line ADE over there, and BCF are drawn. And then it says chords AB and EF are shown. Oh, they are drawn as well. So they're just explaining the sketch here. Prove that EF is parallel to AB. Where is EF? EF is parallel to AB. We have to prove that they're parallel. Well, if these are parallel, we have to think of certain laws, you see. And luckily here, let's focus on how these are both cyclic quads. Look, cyclic quadrilateral over here. So we can use cyclic quad laws. And then here, cyclic quadrilateral, because you see all 4 points are touching the circle. So that's a big bonus. So what we already know is, if these are parallel, technically we have to prove things. We have to use things like fun to help us. So the first thing I can already spot here is that Well, opposite angles of a cyclic quad have to add up to 180, so let's keep that in mind. So for 5 marks, let's be chilled. Let's not hurry. Let's not be in a hurry. So let me try and use, they said here we should prove that EF is parallel to this. So I'm going to try and prove that these add up to 180, because of co-interior angles. So where would I start? Whichever ones. Either prove these two to be 180, or you can prove these two to be 180, like this one and this one. You see, whichever one. Let's see what we can do. Let's just write out laws galore. Laws galore. So here the first thing I'm going to say is that BE is equal to C2. No, E plus C2 is equal to 180. So yeah, you may be asking, what's your train of thought? Well, you see, I'm just going to write out stuff until it comes out. Literally, it's just weird, but what we're trying to remember, we have a goal, so it's fine. So E plus C1, E plus C2 is equal to 180. The reason is opposite angles of a cyclic quad. Okay, that's that. Perfect. Now we know. Now we have a value for C2. The reason why I want a value for C2 is because I want to say that C2 is equal to this. So let's just isolate C2 here. C2 is 180 minus E. Yeah, let's do that. Fine, 180 minus E. This is a conclusion, you see. So the next thing I'm going to say, remember, is C2 is equal to A, and then exterior angle of a cyclic quad. C2 is equal to A. The reason is exterior angle of cyclic quad, you see. So here now I have C2 here, you see. These two are perfect, you see. So I have C2 here, I have C2 here. So here I can say, therefore, 180 minus E is equal to A, which is 180 is equal to A plus E. Boom! You see, E here plus A, we have said they add up to 180. So here, therefore, these are parallel because we proved co-interior angles. So EF is parallel to AB because angle A and angle B are co-interior angles. Co-interior angles. You see, we're proving that there's a co-interior angles. They're co-interior angles because they add up to 180 degrees. You could have used whichever pair you want. It doesn't matter. I literally, it just came out while doing the stuff, because using those laws. This was an easy 5 marks. So thank you very much. Moving on to question number, is there a number 8 point something? No, it looks like we're going to go to question number 9 straight away. Question number 9 in this 2015 grade 12 mathematics paper 2 final exam memo, we are looking at this diagram. They say it here in the diagram below, ABC is drawn in the circle. Okay, then it says TA, where's TA? TA and TB are tangents, so they are equal to each other. Let's throw that in there. And then they say it here, the straight line THK is parallel to this. Okay, so we have to remember fun, you see. And then they say it here, it is drawn, it is parallel to AC with H on BA, okay, and K on BC, okay. And then it says AK is drawn. So I'm just reading the statements while linking it to the sketch. That's why I'm not reading it fast. That's why it's not even like it's being read naturally or anything, because who cares about reading naturally? It's all about the statements and whether or not they're in your head. But anyways, let me keep talking. No, let me keep quiet and just work. What the hell? Let A3 equal to X. Where is A3? Okay, fine. So the thing is, the given description is important, but it always just links to the sketch, so you don't want to skip it either way. So here it says for 4 marks. 4 marks? Oh. They said prove that K3 is equal to X for 4 marks. So 4 marks is not a joke, so you have to pull your weight a bit. So what you do is don't just focus straight on trying to get this being equal to that immediately. You have to chill a bit, What I mean is just get values that are equal to this first and then work from there. So the easiest thing is firstly get values equal to x. You see I even tilted the sketch because here you can see you have the 10 chord theorem. So if this is x, this is clearly equal to x. So get values equal to x first. Why? Because of the 10 chord theorem. You see A3 is equal to C, which is technically equal to x then, because of the 10 chord theorem. So let's start by getting values equal to x. So let's say here A3 is equal to C, which is equal to x because of the 10 chord theorem that we all love. So this being said, now we have a value equal to x. Now you look for other values that are equal to this, you see. So let's think of how we have what do we have? Parallel lines here. So let's see if there's some alternating angle stuff going on. No. Well, what you can then do later also is look for values that are equal to K3, you see. So let's think of stuff that is equal to K3 specifically, and just, oh, ha 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 ha, this is so dumb. Corresponding angles, you see. K3 is equal to C, which is equal to x. The reason is corresponding angles. Yep, you see, just by looking at the sketch, it came out, like, it just came out, you see. That's why fun is important, because parallel lines, don't underestimate them, you see. So we're proving that they're both equal to C. So they're equal to each other, you see. So here, therefore K, no, we wanted to prove that it's equal to X. So that's it, we're done. Okay, I was about to add extra work here, because it's this answer, this answer. Okay, fantastic. I thought they wanted us to prove that this is equal to that. Oh yeah, they wanted us to prove that this is equal to x. So it's the same thing. Whichever way, you're proving that it's equal to x. So that will give you your 4 marks, because 1, 2, 3, 4 things. Very easy 4 marks that. Like, very generous of them. Thank you very much. Anyways, prove that AKBT is a cyclic quad for 2 marks. AKBT is a cyclic quad. Well, this one is easy, because if you're going to prove a cyclic quad, there are 3 ways to do it, which you can go through in the playlists and stuff. But one way to do it is to show that angles being subtended by the same chord are equal, which is exactly what we're getting here. There's T here, there's B here, this thing should be steady now, and then there's A here, and then there is, what is this thing here? This is K. You see, if you look at that, this is A. Hey, paper, please stay to the floor. And then you see, we're proving that this is X, we're proving that this is X. So that's our ticket to say that this is a cyclic quad, because angles are equal. Angles subtended by the same chord are equal. So you see, that's why it's only a 2-mark question here. 9.2. So you're going to say that let's just show them what A3 is equal to K3. This is proven. So therefore, AKBT is a cyclic quad, because it is a cyclic quad. Oh, how do you spell cyclic quad? QUA, yeah, cyclic quad, because angles subtended by the same chord, are equal. Okay, angles subtended by the same chord are equal. Perfect. And then here it says, what else? 9.3. It says, prove that TK bisects AKB. Where's TK? Prove that TK bisects AKB. Oh, we have to prove that TK, the line TK, it cuts, we need to show that it cuts AKB in half. So the only way to do that is to show that these are both equal to each other. So we just need to show that this is equal to x. And okay, that's going to be interesting. Well, the thing is, this is a cyclic quad now. We know that this is a cyclic quad. So let's try and exploit that. This, and this is a cyclic quad. So what do we know? Well, technically K2, well, we want to say K2, we want to show that K2 is equal to x. So the first thing we know is K2 is equal to B2. Okay, that's perfect. Let's see if that's going to help us in some way. Let's think of our 10 chord theorem quickly, because our 10 chord theorem works miracles, this one. So let's see here. If this is x, technically this has to be x. See, because of our 10 chord theorem. Yep, let's do it. 10 chord theorem. We love the 10 chord theorem. So let's just say B2 is equal to X. B2 is equal to C because of the 10 chord theorem. So it's also equal to X. So let's see here. Yeah, let's do that. B2 is equal to C, which is equal to X because of the 10 chord theorem. You see, so we've shown that B2 is equal to X as well. Now we need to say that B2 is equal to K2 because they are angles subtended by the same chord. You see, because technically you have a circle around here. You see, so this is a cyclic chord, so angles subtended by the same chord have to be equal. So here B2 is equal to K2, which is equal to X because it's angles subtended by the same chord. You see, so you may be thinking, but they're not in a circle, so why is the law holding? The law is holding because you have proven that that's a cyclic chord, so there's a circle that can be drawn around those 4 points there, so you can use your circle laws. Dope. So you've proven that B2 is equal to K2, you see, so you've also proven that this is equal to X. You see, you've proven that this is equal to X, and you know that K3 is equal to X. So here, therefore, K2 is equal to K3, which are both equal to X. That's a conclusion. So I can then say, therefore, TK bisects AKB, because if it bisects AKB, it means that it cuts that angle in half. So if they're both equal, it means you're safe. So this is 9.4. The next one is 9.4. For 2 marks, it says, prove that TA is a tangent to the circle passing through AKH. Let's see here. AKH, right? We have to prove that TA is a tangent passing through those points. Well, this one is easy because it's also 2 marks. So if this is a tangent, right, to a circle that passes through these points. So if you have a circle there, it means that you should be having the 10 chord theorem, you see, because if this is a tangent, you have a tangent there and you have a chord. So this angle has to be equal to that one. As long as these are equal, you have the 10 chord theorem there. So automatically this is a tangent to the circle that will pass through those points, you see, because you have a circle there. This is not a very nice circle, but I think it will do the trick. The dumb looking circle. So here, this angle at the tangent will be equal to that one. We are seeing they're equal. So yes, you can definitely draw a circle there where this is the tangent. So for 2 marks, that's what they want us to say. So here, let's show them that A3 is equal to K2, which is equal to X. That's proven. They're both equal to X. Therefore, TA, you see, because this is A3 being equal to K2. So TA is a tangent to circle AKH because of the 10 chord theorem. Because of the 10 chord theorem. Yep, let's just move on. I really want to finish now. 9.4 says S is a point in the circle. But where is S now? There's no S anywhere. Sharp. We'll have to put it in there. S is a point in the circle such that the points A, S, K, B are concyclic. Okay, S is a point in the circle such that points A, S, K, B are concyclic. So let's see here. Where is A? There's A here, there's K there, and there's B. So if S was somewhere, it would be maybe somewhere here. Because somewhere here. Because concyclic means that there are points on the same circle. That's what concyclic means. So it says explain why ASBT. Wow, this is so annoying. S is a point in the circle such that AS K, B are concyclic. A, somewhere there will be S, B, K are concyclic. Well, maybe somewhere here. Oh yeah, somewhere here. I think S would be somewhere here. That would make better sense, because it's like a circle here. You see, you could draw a circle there. If S was somewhere. Oh, no, there is S. Ah, this is nonsense, man. I couldn't see that. S is a point in the circle, yes. But did they mention S in the description? You see why I'm annoyed? Because they didn't mention S anyway here. Ah, that's annoying. But anyways, it was in the picture. The sketch is all messed up, so of course I'm going to miss this. It says here, S is a point in the circle such that A, S, K, B are concyclic. They mean that those points can be drawn on the same circle. Then it says, explain why A, S, B, T is also concyclic. Wow, that's an interesting question. So this one, well, obviously, you would definitely need to dig deep. Not dig too deep, because I mean, if it's not your cup of tea, if it doesn't seem like it wants to work out, then you can just leave it. But here, let's see here. Let me just think about it actually. Well, to make things easy, right? We already know that this is a cyclic quad, you see. So there's already a circle that passes through A, K, and B. You see, we already know that there's a circle that does that. So technically, if they said we have a circle that can pass through A, S, K, B, A, S, K, and B, why do they even have to write them like that? That's so annoying. A, S, K, and A, S, K, B. Yeah, if there's a circle that can pass through A, S, K, B, technically there's also a circle that can pass through A, S, B, T, because we have a cyclic quadrilateral here. This is one of the dumbest questions I've seen in a long time. Yeah, because what the hell, guys? Like, why? How is this all necessary? But it's fine. So the easiest way to put this is, right, for 9.5, you can basically say there, you can basically use what we have here first. You see, A, K, B, T is a cyclic quadrilateral. So here, A, K, B, T is a cyclic quad. This is proven, right? So we know that there is a circle that already passes through A. Where did we say here? So I'm mixing my words now. AKBT. AKBT. We know there's a circle that does that. So we know that if you have a circle that goes through the points A, S, K, B, that's fine. These are concyclic. They say they should prove that. Explain why A, S, B, T is also concyclic. Because, I mean, a circle passing through the points A, K, B contains the point S, right, on the circumference. And then, I mean, the circle passing through AKB contains point T on the circumference, because we proved it in the previous question. That's the only thing, because I feel like this is the dumbest, weirdest, most annoying explanation ever, because S is a point in the circle, yes, such that these points are concyclic. Explain why A, S, B, T are concyclic. Yeah. So if these are concyclic, it means that A, S, B, T also have to be concyclic, because A, B, K, and T already are in a circle, because that's a cyclic quadrilateral. So this is a cyclic quadrilateral. It is proven, you see. So A, S, K, B, yeah, A, S, K, B are concyclic. Yes, these are concyclic. Explain why this is also concyclic. Yeah. Let me just say here. So A, S, B, T are also concyclic. It's a 2-mark question, so my reason is these are concyclic because A, K, B, T is a circle already, you see. So if we have a circle there, the circle is bound to pass through point S. We know that there's a circle there because we have already proven it. That's a cyclic quadrilateral. So this, I would fight for my 2 marks like nobody's business. Anyways, moving on to question 10. Question 10, let's hurry it up because this paper is getting bloody darn annoying. I know, I feel it too. It says here in the diagram below, BC is equal to 17. BC is the diameter of the circle, so this is equal to 90, thank you. Then it says that the length of the chord BD is 8. The tangent meets CD at A. Oh, okay. Thank you. This is a nice question because you see there's so many values given. I feel so much better just looking at this question. The first thing is they said we should calculate the length of DC for 3 marks. Well, it looks like here we're going to use some proportionality stuff. Yeah. No, we don't have to. So this is 17, right? Meaning this is half of 17. This is half of 17. So, yeah. Why did I rush into this question? Well, I rushed into it because it seemed like an entertaining question. But now I feel like I am entertaining it. So the easiest thing is, I mean, this is a right angle triangle. Why am I overthinking it, man? Come on, just Pythagoras. D, C, I think I'm getting tired now. Like I should calm down because look here now. This is B. This is C. This is D. Pythagoras theorem. So we know that BC squared is equal to BD squared plus DC squared. So BC squared is 17 squared. This is BD, that's 8. This is DC squared. So let's just maybe tell them that this is 90 first, you see. BDC is 90. BDC is 90. Why? Because it's angle subtended by the diameter of a circle. By diameter of circle. That's it. So here, let's just take this. This is squared. So it's 17 squared minus 8 squared is equal to DC squared. Squared both sides. Let's see here. DC is going to be equal to, let's check with the calculator here. DC is going to be equal to 15 because if you add those two, that should give you 225. Square root it, that's going to give you 15. So we have 15 there. Thank you very much. Let's just keep on going because we have, let's go. E is a point. There's E. Okay, E is a point on BC such that the ratio here is 3:1. Okay, EF is parallel to that with F on DC. Okay, calculate with reasons the length of CF. Well, I mean, this one is easy because if the ratio here is, if the ratio between BE and EC is 3:1, then the ratio here is also 3:1, meaning we just need to divide 15 using the ratio 3:1. So yeah, we have to use the ratio 3:1. Where is this question? 10.2.1. 10.2.1. We have to divide 15 in the ratio 3:1. So all you do is you say 3 plus 1, which is 4. You see. So the big portion is technically E, is technically DF. The small portion is technically FC. So here, 3 out of the 4, this goes to DF. And then 1 out of the 4, this goes to CF, you see. So you see 1/4 of 15 is, well, technically whatever CF is, which is just 15 over 4. So CF, let's see what CF is in the calculator. 15 divided by 4, that's just like 3.75. So yeah, 3.75. Moving on, it says here, prove that BCA is similar to FEC. Okay, so you have to prove that this big one here, right, is similar to this one here, this tiny one. Well, that's going to be easy because firstly, they're already telling us that you see the B here, you should match it with the F there, and we can already do that. You see this, they're both equal to 90. So let's do that first. We have to prove that all the angles are equal. So let's start by showing that this is 90 and this is 90, because you see this is 90. These are corresponding angles. So let's say here 10.2.2 let's just start off by saying that, you see, ABC is equal to, no, let's just say that EFC is equal to 90. EFC is equal to 90, which is equal to BDC. BDC, the reason is corresponding angles. You see, so we're proving that this is 90. Now we need to say this is equal to that, you see. So ABC, you see, ABC is equal to EFC. EFC, which is equal to 90. See, this is a conclusion. We're proving that they're equal to 90. You see, so we've proven that one set of angles are equal. The B here and the F there. Now we need to say, you see, for this big triangle, we have to show that the A is equal to the C. Well, that's going to be a bit difficult. No, the A, we have to say it is equal to the E. Let's see if that's possible. The A here, we have to say it is equal to the E there. Yo, high corner. That one looks funny. Well, C, oh, C is the easy one. That one, the middle one is actually the hard one. The C's are the easy ones because C is a common angle, you see, for the big one there and for the tiny one there. C is a common angle. So let's just do that. C is equal to C, common angle. You see, so we've proven that at least two sides, at least two angles are equal. So the last ones, which is this one, like we said, and this one, this automatically will be equal. So BAC, if you want to call it, BAC is equal to FEC. FEC. The reason is interior angles of a triangle. BC, because if you're proving that at least two sides, if you're proving that at least two angles are equal, the third one's automatically are equal. So here, therefore, these are similar. You see, therefore, this triangle BAC is similar to triangle FEC, and the reason for that will be angle, angle, angle. You have proven that all three angles are equal to each other. Very easy question, that one. Moving on, no time to waste for real though. 10.2.3, they say they calculate the length of AC. This is quite interesting. For 4 marks. Yo, these guys are not playing at all. But anyways, so what we can do for ourselves is, I mean, if you want to get the length of AC, then we can use proportionality theorem stuff. So what we already know is that these are similar to each other, you see. So automatically what you can write down is, you see, there's BAC here that is now similar to triangle FEC. So you can write out stuff like BA over FE. BA over FE is equal to AC over this, AC over AC, which is equal to BC over FC. BC over FC. You see? So we want something that has AC in it, so we can use this. We wrote this because of the proportionality theorem. Proportionality of similar triangles. So we have something that is AC in it. Let's see if we have EC. Well, we can get it if we need it. And then let's see what else we have. BA. No, we don't have BA, so let's leave that one out. Do we have BC? BC we have. Do we have FC? FC we have. So let's use these two here. So here AC over EC is equal to BC over FC. Perfect. So let us get, what can we get? We can get EC first, you see, because EC is here. Remember they told us that the ratio of B, the length of BC we have, and the ratio of BE and EC is 3 to 1. So we can divide 17 using the ratio 3 to 1 to get a value for EC. So 3 plus 1 is 4, you see. So 3 out of the 4 will give you BE. And then 1 out of the 4 will give you EC. You see. So 1/4 of 17 is whatever EC is. And then 1/4 of 17. And then EC is 17 divided by 4. That's like 4.25, so it's like 4.25. That's EC, right? So we have EC here. Perfect. Now let's just throw in all our values. You see, AC we don't have. EC is 4.25. BC, we know it is 17, the whole thing. And then FC, we worked it out to be 3 was it? I think it was 3.75. 3.75. And then here, working out AC, you can just multiply by 4.25 on both sides. 4.25 on both sides. This cancels out. AC, let's see here, 17. 4.25 over 3.75. In your calculator, let's see what this gives us. 17. 4, what? 3, no, 4.25, 3.75. That's going to give you 19.27. 19.27. Great. No time to waste. This question is dragging on for a bit too long now, for real though. Then the next one is write down giving reasons the radius of the circle passing through A, B, C. So how many marks? 2, thank you. A, B, C, the radius of that circle. Well, if this is 90 degrees, right, it means that the radius is going to be half of whatever AC is, you see. So AC over 2 equals radius, right, because AC is the diameter, you see, because ABC is equal to 90 degrees. So you see, if this is a 90-degree angle, it means that this is the diameter of the circle they're talking about. So half of AC, which is radius, is going to be the half of 19.27, which is in this case just going to obey. Let's check here in the calculator. Where are your calculator? Cut you in half. That's going to be 9.63. 9.63. Okay, seems to be going well, I guess. Not too bad, not too shabby. But yeah, some of these questions, they are not the nicest of questions. They're low-key a bit annoying, but hey, that's math for you, I guess. So the next one, we just have to carry on. Let's see here. What's the next one? Yeah, let me just double check this answer here. Let me see if I made a mistake or any sort. Just double check here. It doesn't look like I did any funny business here. So yeah, radius of the circle. Okay, moving on to question 11 then. No time to waste. Whew, finally, man. Like, this feels good. Question 11 looks okay, I guess. Oh, let's just not underestimate it. Excuse me. There's just so much information given here. It says here, for 1 mark, complete the following statement. If sides of 2 triangles are in proportion, then the triangles are similar. Similar. Boom. Give us the mark. Here it says in the diagram below, K, M, N, respectively, are points on sides PQ, PR, and QR. And then they said here it is of triangle PQR. And then they've just given us values. I mean, like, look, this is this, 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 this is this. So my assumption is these sides divide each other proportionally. Because look, you see 1, this is double. There is 0.75, this is double. There's 1.25, this is double. So automatically, these 2 triangles are similar because their sides divide each other proportionally. Boom. 11.2.1, let's see. Prove that K, PM, and R and M are similar. Well, we just did it. Let's do it now. Show them for real. So here we know that MN over, well, let's just show them. MN over PM is equal to 1 over 2. 1 over 2. Let's take another pair. RNR over, it has to be this one because this one is the double one, over PK is equal to 0.75 over 1.5, which is 1 over 2. And then the last one you can basically say is MR over KM. There is 1.25 here over 2.5, which is just a half, you see. Therefore, this one is the easiest one, like really. Therefore, triangle KPM is similar to triangle RNM. It's like the first statement gave us like a hint, you know, because here our reason will just be sides divide each other proportionally. Okay, 11.2.2. Oh, look at that, the last question. I'm so happy. Determine the length of QN. Yo, hierdie mense, hoekom wil jy weet wat die dinge is? Like, why? Like, why you gotta make things so complicated when we're just having fun here? Like, it was so good. Like, why? Why are you doing this? But anyways, it's fine. We'll give you what you want, you know. So the one thing that I will do here is, firstly, let's see here. Let's try and be sober, you know. Don't overreact. Let's just be chilled. So if these two are similar, and then you have this big triangle here, yeah, for 6 marks, I promise you, this is not going to be a very easy question. It is going to be madness. And man, yeah, that's just what it is. But what I would actually do is I would actually redraw this sketch. Watch me redraw this thing. So I mean, look at this, right? If these are proportional, it means that, look, which ones go together? Well, we say let's label them nicely, because I just put a dot. That's just so not nice. This one goes with this one, okay, and then this one goes with this one, okay, and then if you look closely, this one goes with this one. Okay, so let me finesse this question real quick. So it's a last question, so you have to pull out all the guns on this one. So here, you have to pull out all the stops. I mean, let's not talk about what I just said right now. So this is our big circle. This is our big sketch. Now what I want to do is I'm going to flip this over. I'm going to flip it over. So it's going to look like this. Don't be angry. Don't be angry. Okay, just chill. Just chill. I don't even know what I'm doing. But anyways, this one means this would be M. This would be K. And then automatically this is still just P, you see. Now I want to put this shape inside this one. So meaning I would also have a line over here. And then let's see which ones go together. Well, N, which ones go together? Well, here we have this and this. There's this and this. So yeah, so the K has to go with the R. So this has to be R here. Up here has to be N also. And then if this is NR, this has to be M. For the... Oh, okay. This is quite interesting. Uh-oh. Somebody is gonna be angry at me a bit, I think. So this is Q. And then technically this is R. Woo! We have to get QN. Hey, yeah, nah. Let me actually pause here. Actually, let me just carry on with this. So, yeah, this is, again, I think there's like a level 10 kind of question. I know I said what I said. So anyways, we see what we did here. This picture, we just flipped it over, you know. So we have M here, we have K there. And then we still have P at the top there. Fine. Now, we said this triangle here, because it's similar to this one, we can mesh the two, you see. This triangle here, we can write it like this. Now, what we have done is, automatically we know that these have to be parallel to each other, because they are. But so far, let me just write out what we know about our proportionality theorem here. So from 11.2.2, from 11.2.1, we already knew that these are similar. So A, P, M, and then we have this is similar to triangle R, N, M. So this is again the last question. So if you don't get it, I understand you. So anyways, let's just write out what we know so far. KP over RN is equal to PM over NM, which is equal to KM over RM. And then the reason for this is just proportionality of similar triangles. You see, that's what we know. Now the big idea is, you see, with our original sketch, as long as we have a value for Rn already, so what we technically need is a value for Rq, one or the other, because if you can get Rq, I mean, you're safe, because you can say Rq minus this gives you Qn or Nq. So let's carry on. Hooey. Yep. What would I do next here? So with my diagram, right, the next thing that I would do is I would prove that, what am I trying to aim for here? I'm trying to aim for getting a value for Rq. So let's just show that we have KPM here. We are going to say that it is similar to our big triangle here. Yeah, it's about to go down. But anyways, let's do it. In triangle, let's label it RPQ. And triangle, well, technically we'll have to label it KPM. Firstly, we have P as a common angle. P is equal to P. That's a common angle. Okay, so that's the first angle that we have said is equal to each other. So the next piece of information that we can use to show that these two are similar, well, technically if you look at PKM, let's look at PKM. So if you look at PKM, right, we know that this angle here is technically equal to R. And our reason for that is, remember, PKM, where is PKM? PKM, you see this angle here? We have proven that it is equal to that angle there. The reason is, you see these two, you have the exact same proportionality happening there. So let's just say that PKM, or in our case, PKM is equal to whatever R is, and this is proven in 11.2.1. See, proven. So therefore, so we're proving that this is equal to this. We're proving that this is a common angle. So therefore, this has to be equal to that, because interior angles of a triangle. So here we can say, therefore, PMK is equal to PQR. PQR. The reason is interior angles of a triangle. You see, therefore these are similar. Therefore, this is similar to that. RPQ is similar to triangle KPM. Okay, I think we're almost home free. Would you believe it? Yeah, this question, guys, like I told you, this is like one of the toughest questions you can find in your papers. So it is what it is. So anyways, because we have proven that these two triangles are similar, right, we can now write out things like, if RPQ is similar to triangle KPM, then RP over KP is equal to PQ over PM, which is equal to RQ over KM. The reason for this is proportionality of similar triangles. Whew. Okay, so now where are we? I feel like we've juggled and now it's time to finish it, because this question is very complicated, and I understand you, and I'm sure my sketch is also like messing with your head a bit, so sorry about that. But anyways, let's see here. So what do we know? We said we want a value for NR. So what can we use? We have a value for NR. We said we want a value for QR. So because let's go back. Where can we go back here? Where was I? One God, I'm getting confused at my own question. So yeah, NR we have. Let's see if we can get QR. You see where QR is? We have QR or RQ here. There's RQ here, but then there's KM as well. Let's see where KM is. Do we have KM? Yes, we do. Perfect. Let's see what else we have. Do we have PQ? Where's PQ? PQ we don't have. Do we have PM? PM we have. Perfect. And then do we have RP? Where's RP? RP, technically we have that if we need it. Do we have KP? KP we have it. Oh, perfect. This is working out just fine. So this we have in full. This we have this, but we just need RQ. So here we can say RP over KP is equal to RQ over KM. And then here we want a value for RQ. So you see KM, we already know what KM is. KM is 2.5. 2.5. RP, where is RP? RP is these two put together. So that's 3.25. 3.25. And then you have KP. KP is 1.5. So that's 1.5. And then getting RQ, you can multiply by 2.5 on both sides. So this goes away. You have RQ here. This is going to give you what in your calculator? Let's see here. So it's technically 3.25, the whole thing over 1.5. This we're multiplying by 2.5. So this is giving us, let's just write it as a fraction. This 65 over 12. So this is RQ. Now we are home free because we have RQ, the whole thing here. We have RQ, right? RQ, we know that RQ is what we have gotten. So that value RQ minus Rn is going to give us Qn. So let's do that. RQ is equal to NQ plus NR. Yeah, because NR there plus NQ gives you RQ. So this is 65.12. NQ is what we're looking for. NR is 0.75. So this goes over, so it's 65 over 12 minus 0.75. This is NQ. So NQ, let's see here, 65, 12 minus 0.75. That's like 4.66666. So let's just say 4.67 if you round it off to 2 decimal places. So yeah, this question is just madness. Like, I kid you not, this paper was not so bad, but towards the end, it was just madness. Like, look at what we had to do here. Like, we had to finesse stuff. And this is all valid. I know it doesn't look like it's a valid expression, but this is just so that you can visualize what's going on, you see. Yeah, it's for visualization purposes. But like I said, if this question is just one of those questions that are throwing you off, I think that should be fine, because you see, it's a wildcard question. It's a proper wildcard question, because out of 6, it's right at the end. So don't assume that it's going to be easy at all. It is definitely going to be a monster of a question. But anyways, let's just end it here. It's the last question. I'm so happy. So don't forget to subscribe. Don't forget about the courses. You know, the link is in the description, so that you can definitely dig deeper into different topics, so that you can understand them and get those distinctions.